Okay, so hello. Thanks for keeping up to this time. The last talk, it's not easy to be there. Sebastian proposed me to do a talk, so I was reflecting a lot on what should I talk about, what can I talk about, and finally I think the subject of multi-tenancy is something that it's really important when you try to build your own cluster, when Kubernetes cluster I mean, and when you have to choose, to decide on various aspects of what can you do, what's possible, how to integrate it, of course on premises, because we're not allowed to do cloud yet, at least for production. So this subject of multi-tenancy, I think it's key, and I would like not to say what we actually did, but what actually we learned while doing this. So, okay. So about me, I'm a software engineer, architect. We are working on I'm in a platform team, so we provide the platform support for all applications developed in-house. It's mostly Java, so I'm responsible for that part. And I've been working on Kubernetes since the beginning of 2017, and it's been a really nice ride so far. Looking forward to go there, continue. About Pictet, so it's the third largest private bank in Switzerland. I will not go through all the numbers there. The only things that I think are worth noting is that with regards to the number of servers, most of them, so 90% of them is virtualized. Why talking about virtual servers in a BareMetal Kubernetes? Because in the end, the idea is to share resources and all that yields to some kind of multi-tenancy. About Kubernetes, we have 8 clusters so far, and a few applications in production, and there's a lot of interest from the developers in moving more and more into that. Okay, so we're going to do a bit of a theory about multi-tenancy, and then actually go through what can we do in Kubernetes about that, and what we learned, what was the hard way experience that we had while doing it. So multi-tenancy basically means sharing a part of some resources among several users, several groups of users, and dedicating it to it. Why do this? It's because we can save on the cost, because we share actually the resources behind it, and also in terms of maintenance cost, release management, and so on. But all this is not free. All this comes with some complexity. And we'll talk about that. So then, from the beginning, there are lots of questions that we asked ourselves on what's the granularity of a cluster, of how many clusters, what's good, what's bad, how should we evolve, how should we implement Kubernetes at Pictet. So it's nice to have several clusters, multiple clusters, because this allows to limit the failure domain, allows to limit security issues. But then all this comes with some overhead. So have to set up more clusters and manage them and update them, so it takes time. And also it's a question of integration. It's not just we deploy the cluster and that's it. It has to be integrated with the rest. If it's not integrated, then it doesn't make sense. And then there is some overhead to run it, the control plane of the cluster itself. It's not much, but it can be depending on the nodes. So how many in the end? I don't have a clear answer, but for us, the answer I could say is as few as possible. And this is depending also on the context, because if we would do this in the cloud, I think we would have one answer. If we do this on premises, that's clearly a different answer. What can we do in Kubernetes with regards to multi-tenancy? Well, initially, Kubernetes was not designed for that. So even we say that the namespace is the actual separation domain. Actually, this was more like a logical naming scope for the objects you put inside. But with the time, there was an interest to go in this direction. So there are multiple concepts that were added, like RBAC, like Quotas, and so on. So it moves in this direction. On the other hand, things are not simple. Not simple because of, I think, two main issues. One is that containers actually can leak. So we can talk about soft versus hard multi-tenancy. Soft multi-tenancy meaning that actually I know my workloads, I trust them. It's like friendly applications. Because it's the developers in-house that do them. And then hard multi-tenancy is something that attacking each other. So it's clearly not that the target is not that. And on the second issue is that Kubernetes itself is a platform to build other things. So it's highly customizable. So for example, like Istio, if you want to deploy that, then you will have to use the Istio ingress. Or if you put some operators, then things will make be available to everybody that runs in the cluster. So when you choose something to do in a cluster, then there might be an impact for all the applications inside. So you have to pay a bit of attention. Now, Kubernetes on BareMetal, so why? But I think the idea behind the applications that you run inside is that mostly you should focus on 12-factor applications. So it's not that you cannot do something else, but the idea is to have this kind of applications and to move a bit more of the failure logic of the way things are implemented to the application. So you don't need all the VM features. You don't need that the VM actually can move from one machine to the other without interruption, like you could do with the VM. And a second reason is that actually it could be a way. So if all the logic is already in the application, why adding yet another layer? Because all we do from a long time is that we add yet another layer. Each time we build something and we add another and another layer. So maybe we can try to keep things simple. It's already pretty complicated with all the stack of all applications and all components inside. Why try to add another layer? And on the other hand, I think for an on-premises perspective, it's either way difficult to do it, to install and provision if you don't have some cloud API to build nodes just like that and destroy them. Now, how can you do it? Just isolate at different levels. So we'll have a look on what actually can you do and actually what we learned doing that. So the control plane. So the control plane meaning all the components of Kubernetes. There are a few. You for sure know them. They communicate, as you might know, by SSL. So what we learned is that actually these certificates are a bit of a pain. So how to manage all of them, how to renew them, how to provision, how to deal with all that. Well, we chose Vault. That's great. But then another issue popped up. Well, now we have several clusters. Then we cannot use a single instance of Vault. So it's interesting to actually dedicate a CA per cluster for the needs of that cluster itself. Might not be obvious, For me, it was not obvious at the beginning. Because there are, yeah, sure, for sure, you can trust various things with the CN parts, but it won't work forever. Another issue was with the Helm. Helm itself, yes, you know, it's not secure. But on the other hand, it's not difficult to make it a bit more like the next Helm 3. So we developed a plugin to run Tiller locally when we do the deployment. So that's a pretty good approach, I think. On the human access part, the idea was to restrict as much as possible so that people, developers, and so on don't have direct access to the cluster. So it's like everything passes through the code, through Git, but then, yeah, goes to various lands, because in the end, they will still want at some point to have access maybe to debug the thing. So how does it go? How does it happen at that point when they have to debug something in production? They should come to us always. How we deal with that. And on the other hand, admins have access to everything. So they have access to the secrets. Maybe it seems obvious, but on the other hand, how can we deal with that? How the cluster admins could not have access to some secret of database containing sensitive data? Yeah. Then isolating the workloads. So yeah, there are several things that we can put in place, like quotas. Yeah, great. But for example, there are some applications that are or were not aware that they run in containers. So Java, for example, till last 8 versions, they didn't know that. So when a JVM starts and it says, I have this big machine, I can take all of the cores and all the memory, it's you have to tune it specifically for that. Or another thing that we've seen with the Go applications, that was pretty funny, limiting the CPU of a Go application, at least with the previous version of Go. I don't know if now it's different. It actually, the garbage collector of Go actually didn't have time to clean up. So, but the application continued to run. So at the end, the application was taking more and more memory because of a CPU limitation. And then it exploded, and Kubernetes restarted it. But still, it's not a good thing. Now, with regards to coming back to Java, putting the quotas, meaning that actually it could be that applications start slower in the cluster than they start on developer's machine. So it would have been interesting to find something like you have in the T2 instances on Amazon, something that allows you to run faster for a while and then scale down. For now, yeah. Then it's as we've seen in Lee's talk, containers can leak a bit, could have some issues. Now, what we put in place is using restricted pod security policies, but great, they cannot run as root. But on the other hand, yeah, most of images on public images actually want to run as root, so you have to actually redo them. Maybe anyway, it's a good idea to rebuild them yourself, but anyway, in some cases, you cannot just use them just like that. But hopefully, there are lots of efforts in the community to improve that. So we've seen a lot of comeback of VMs through Kata, containers, gvisor, and so on. So I think this is something that will improve a lot in the future. And if that's not enough, I think you can still dedicate nodes. You can dedicate nodes to some application. Of course, that breaks a bit the idea of Kubernetes, but actually is what we did with some application that needs to access the local disk. That's life. More on this isolation, network policies. Network policies are pretty interesting. They work well. They create, of course, lots of IP tables, but that's another issue. what we've seen is that it's fragile with regards to egress of the cluster itself, because the network policy is there to protect especially workload in the cluster itself. You can protect access to the namespace or between namespaces and so on. That's great. But once you interface your cluster with the rest of the data center and the rest of the services that are outside, it can be difficult, because usually that is protected by firewalls, and if something changes, then who will notify you that the IP has changed to put it in the network policy in your configuration. So another issue is with the traffic encryption. So traffic could be encrypted by some network CNI plugins like Weave, but on the other hand, this could be also done through service meshes. So we are looking forward to test that at some point in the future. Open policy agent, we set that up to check a few things, some preconditions when you do the deployment. So the idea is to make sure that you have some quotas defined, to make sure that the ingress that you define is conforms to some convention that we set, or that actually the pods that are created and the objects that are created are labeled with some certain set of tags, because that is important for the rest of the integration, for example, with metrics and logs later on. More is impact on the host of the workloads. So yeah, they are in a container, and what operating system we should choose. So we went on the Chorus idea. For two reasons, because it was something that seemed like an OS made to run containers. It is immutable, the file system. We can provision it at Bootstrap. We have Terraform, Matchbox, and so on. So it's really easy to set it up, and then it just runs. And if we want to change something, we'll just force a reprovisioning of the node, and then it's recreated from scratch. But there are some issues still with that. For example, we went in trouble with an application that was logging so much that actually it filled the disk. So have to put in place some logs rotation of the containers themselves. This is something that is not there by default. You have to configure that, like you have to make sure that varlib docker is separated, or maybe even that some container doesn't take the whole varlib docker. And then, yeah, as we've seen, it's so simple to create a fork bomb. And so it's something that you should configure somehow. And this doesn't come, there are no knobs in Kubernetes to do that. So you have to go to the Docker daemon configuration and to add some parameters to do this kind of tuning. But yeah, work on it. Another kind of isolation that I think it's really interesting and it's not really obvious. It's with regards to what comes from outside the cluster to the inside. So the idea is, how can you do that? You can go through the ingress, and this is what we ask our developers to go always through the ingress, or not, for example, not using node ports, for example. And we deal with the ingress. We actually configured it for all the applications, and the idea is that this is nice because actually we can limit this way what's reachable from outside the cluster to the inside with network policies, and also we can, for example, with traffic, we can also log each access log entry, and we can make sure that it's being tagged with the proper product that is being run, so that the logs are really assigned to the proper product. So then, when it comes to go to the centralized log management, then each access log belongs to the proper thing. But the issues there are that how can we deal with non-HTTP or HTTP protocols? Well, we don't do that for now. How can we deal with performance issues? Or mostly, I would not say performance, because we don't have such a big number of external users. It's probably mostly related to the number of applications that will be deployed at some point, the number of ingresses that will be deployed at some point, and how to deal with classic means of isolation. Coming back to the IP firewalls. So we had an issue with an application that is deployed in Kubernetes, and we had to make it accessible to some region of the network. So, okay, we opened this in firewall, but suddenly we opened every application which is deployed in our Kubernetes to this area. Is it okay or not? So at some point, we still might need a load balancer. And yeah, on the cloud, it's so easy. Just put a service type load balancer. On premises, no way. So that's still an issue to address somehow. The other way around, going out of the cluster. So, and again, with the same kind of isolation. If you want to access some NFS storage that is, of course, outside the cluster, then how do you protect, since that is protected only by IP address? I won't go into using Kerberos to do that to do that protection. So. For NFS, actually, we managed to implement it ourselves to limit that at the CNI level. But in general, it can be an issue. Like, for example, if you have some Elasticsearch, I don't know, cluster or even instance for which you don't have explicit access security, then basically, as soon as you open access to the whole nodes, all nodes in the cluster to that instance, actually, you open access to all applications that are deployed in the cluster to this instance. So it's something that has to be considered when you deploy into Kubernetes, and also the integration with external world. So where are we today? I think. I would say, based on the goals that we had when we did that, the idea was to have something which is pretty good integrated with the rest of the infrastructure. Because if we don't integrate it, then it means that actually it might not be used. So if this cluster is not a first-class citizen in the rest of the data center, at some point it won't be used. So it should be that when you connect to it, when you use an application that's inside, should be no difference from the outside. And also, for example, when you use the other systems, like I don't know, for example, the storage. We added NFS storage for the stateful applications for our clusters. We would still like to have it at least like on the cloud, so not so with persistent volume claims, meaning that the developers can create them themselves. Also, with regards to logging and monitoring, all the logs, all the monitoring, alerting has to come to the enterprise systems so that they can be seen by everybody. So by everybody that has access to that, of course. And also the alerting is, if something is wrong, that goes to the support team that actually handles all alerting in premises. So this was one part, and the other part was to use a self-service approach, so that we are not in DevOps way to, when they want to deploy something, they should not come to us to say, I want this. No, they will come to us only on the beginning, saying, I want to deploy a new application, it's called like that. We'll create the namespaces for that, and then assign the resources, and that's it. The rest is they should be self-sufficient to go on that. And another idea was, so we have some clusters on AWS for testing, however, a bit of a cloud, for development and testing purposes. And then we want to deploy this on premises for, again, testing and production. The idea of Kubernetes here was also to provide an environment that's similar on the development side to what will be actually in the production side. So the thing, because previously there was some development, let's say doing Docker on the cloud, and then we come on premises and it's I don't know, it's Puppet or something else. So switching from one environment to the other, it's really nice this way. We can apply the same principles from that we do in one environment with the other. And however, what I think it's important is that the deployment strategy is actually the same. So okay, the nodes are created differently. On AWS, we use Terraform for that. On premises, we use VMs, but VMs created a bit by hand, and then BareMetal nodes for that. But once we have the node, the provisioning is identical, so we don't have any difference from one to the other. So it means that when the application comes from one place to the other, it will hopefully work without too many issues. We also use vanilla Kubernetes, so not some flavor. We tested several, but in the end, the idea was to keep the thing as standard as possible, because at some point, I don't know, we might go full cloud, or we might change things. So keep to the upstream to limit, I don't know, to increase our chances to have something that will last more in time. And also with the upgrades, we don't create, of course, we cannot afford to create another set of machines when we do a cluster upgrade. So we roll the upgrades of the node one by one, and it's semi-automated, and I think it will be even faster in the future. But anyway, the storage part, it's something that will be tricky here, because stateless start somewhere, move the other way. But once you have storage, then it's, and storage in the cluster itself, then it could get trickier. Now, to wrap up, I think, so what we've seen so far in these two years is that actually Kubernetes is very flexible, extensible. You can, the Lego part is really there. You can pick and use lots of components, and they work without too many issues. Now, with regards to multi-tenancy, I believe that this is a key point when you think about deploying your cluster. So you really have to take this into account. What do you want? How do you want to isolate? And this actually will also trigger the architecture decisions that you take later on, and also what can people that the application that run inside do. And we've seen there are issues at all the levels, all the way. But some of them can be easily fixed. Some of them require some searching, and then you will find some fix. But anyway, at some point, if you really need separation, don't hesitate to create yet another cluster. And hopefully by the time the whole process will be even more automated, so that it won't be such a pain to create yet another cluster. And of course, that was just an overview. The experts are on the internet, and lots of interesting materials over there. Don't hesitate to look into that. And I would like to finish by saying thank you to the community for this kind of project and developing it in the open and having public exchanges. I for sure follow lots of GitHub issues and try to understand and try to find the direction where the thing will go, and even try to contribute a bit if that's possible. So that's really, really important. I think it's one of the great success of the project itself, of Kubernetes ecosystem itself. And then I would also like to thank my colleagues from the department, because it's not something that you could do if you plan to do this in your at home. It's not something that you can do by yourself. You have to talk with storage people, you have to talk with network people, you have to talk with LDAP people, depending of how, with monitoring people and so on, depending how much you want to integrate and what's the experience that you want to provide to your users, to your colleagues. And also, I would like to thank my developer colleagues that they are willing to adapt to all these constraints, because actually doing this in this way will actually mean that they will have to change a bit the way of how they do the applications, go more and more into this 12-factor idea. It's something they also want, but on the other hand, yeah, there are restrictions. Yeah, the container cannot run as root. Yeah, you cannot mount this and that. You cannot. But I don't think that's let's say negotiable, because once we run in this system that's going to be shared, we have to play well together. So that's it. If you have any questions.